Okay, thanks for your patience. This is going to be a really cool stream. I'm going without Toad this morning. Toad is dealing with some corporate laptop issues that I know everybody has dealt with. This may not be like the full hour or whatever. Of course, we're starting 14 minutes late, so maybe it will go to the top of the hour. There's a few things I want to talk about. There's really two main things. The first thing is something that has frustrated me for a few months in some of the way that the back end has worked. There's been a bug that I thought was innocuous, but ended up not being crazy innocuous. And so I want to accomplish two things. I want to explain the bug, and I also want to apologize that it impacted the people that it did. I'll get into this, but the nature of the bug actually allows me to be precise with the number of people that were affected by it. I know that, 8%? I think it was 8%, yeah. Yeah, 0.0769% of people. Sorry, 7.69%, sorry, of people were affected by this bug. And because of the nature of the bug, I'll explain it. That's how, there's a specific reason why I'm able to be that sure. And for those in that unfortunate minority, you probably had a pretty bad NRA Labs experience for the past few months. And I don't want to spoil it. I'll get into it. So really the thing that I want to do is go through that. I'm going to whiteboard that because I think it's interesting. It's just cool to have not only found the source of the bug, but also be able to articulate why. And then, of course, to offer my apologies because I didn't think it was as much of a problem as it was. So even though it was a very small number of people impacted relative to everybody else, and there were ways around it if you figured out like how to launch your browser in like an incognito mode would have fixed it. There's a few things that would have fixed it, but I'll get into the nature of the bug. The main thing there is to dive deep on it, just to explain some of the architecture that led to this. Also to set up the stage for something that we're going to be doing in the whole Antidote version 1.0 plan, which you're going to start hearing more about that. We're starting to get closer and closer to an idea of what we want 1.0 to look like. We put NRE Labs out there. We launched in October of last year, and I got to tell you, it didn't go through that much development prior to that. This was not something that that we sat down and did over 2 years. It was 4 months, and I had a baby in the middle of that. So it's there were certainly shortcuts taken to make sure that the platform got out there. We've said from the beginning that NRE Labs was never meant to be something that Juniper just put out there. It's here's Juniper's automation knowledge for you, and we preach it down from the mountaintops. No, the work that I'm doing is not Juniper specific. It's never been Juniper specific. I'm doing this. Basically, I'm doing the same work as I've always done. It just happens to be on this project, and it happens to be for Juniper. Juniper's paying me to do this, but the purpose of this project has always been to provide a platform for democratized curriculum, a way for us to come to a consensus on what automation means to us through tangible examples, while also solving the problem of, how does somebody that doesn't know automation at all get started by consuming things very easily in the browser, which we've all talked about. So to that end, we put this out as quickly as possible because again, this isn't a Juniper product. It's effectively a side hustle, to be honest. Is the way that this came out. And the whole reason we wanted to put it out early was because we wanted to prove out the concept of curriculum as code. And by pushing the platform out as early as possible, we get people thinking about that as early as possible, which means that the curriculum becomes much more of a community effort. Instead of something that, again, we baked behind closed doors for a year or two. That's not what we wanted to do. So anyway, the reason I say all that is that comes with trade-offs. If you want to put something out very quickly, you have to make certain decisions, and this is in the truest nature of technical debt, not the way that most people use the term, but in the truest definition of technical debt. I made decisions in the creation of a lot of the back-end platform that was explicitly designed to keep things simple and quick and cheap and cheerful, and there are definitely trade-offs there in terms of how well the backend scales, which is why we have a static number of virtual machines right now serving this up. So a lot of what I'm about to talk about is going to change. In fact, everything that I whiteboard, you can probably safely assume that it won't last for 1.0 because the whole architecture of how state is managed in the backend of NRE Labs will change. But I think it's a useful exercise regardless. So just keep that in mind. I'll probably disclaim that once more when I get whiteboarding. The thing that I'm whiteboarding isn't meant to educate you on like how the back end works, because that's how it works now, but it probably won't work that way for a while, or in a little bit it will change. Probably the next few months. So that's one thing I want to cover, and then towards the end, you know what? I'll do this now. I'll do the whiteboarding last. So there's a few things. We have certainly, obviously, this stream being one of them, many community efforts that we're trying to do to build a community around the curriculum that we're building and the platform that we're building. So naturally, like I said, one of those things is this stream that you're watching right now. Another one is our Discord channel. We have a Discord channel for sort of real-time communication. If you're not familiar with Discord, by the way, it's kind of like Slack, but better. It's like it has a lot of the things people like about Slack, but a lot of other stuff as well. And in addition, it just has a better authentication model, so you don't have to authenticate per server that you're going into. You just kind of authenticate once. There's a bunch of other stuff that's cool. One thing that even was missing from that, though, was the idea of real-time that obviously is really good for real-time communication, but one thing that's missing from that, as is missing from Slack, one of the reasons I don't like when open source communities center around Slack, is that all of the communication that takes place in there is ephemeral. Even if you pay for the paid offering for Slack, which many open source projects can't, and so they don't. But even if you did that, it's still a very walled garden, meaning the way that people find information about your project, normally through Googling, all of the information that's being disseminated within that community is not available to Google. Like, you have to sort of be in the community and be listening all the time, or at least know what you're searching for. Having content out there that is public means that it can be Google indexed. And I know it's free to join Discord and Slack and all of those things, but I'm talking about how easy it is to find information. And I think a lot of people learn that way through Googling. And so one thing that we want to do is find the right. First off, we don't want to have a bunch of different communication methods. We want to center on one or two. We played around with the idea of using Google Groups, which is a way of basically providing an email distribution. But because it's Google Groups, they publish the information there to a page, and then they index that. And so that actually does accomplish that purpose. But then we started thinking of other things that we wanted to do, like in terms of future, like gamification, and not the weird cheesy way, like more like just keeping track of what you've done, and effectively creating one of the ideas we've been playing with is creating this sort of profile of a lesson, either a learner or a teacher or a contributor. Either way, building kind of a profile of what that person's good at. Not good at, that's not the right term, but kind of the things that they like to focus on. Like mine would be testing, no doubt. That's one of the things that I have loved focusing on for a long time. Network automation, testing, and testing in general, even in the software space. So basically, we wanted a platform that allowed us to do certain things like that. And email lists are not meant for that. They're email lists. You send an email into this distribution, everybody gets it, and then a copy is made available on the web. And so people can Google for things that you share, and then they find it. But then, of course, all these other goals that we had wouldn't be met. And of course, like I said, I didn't want to have we didn't want to have multiple tools. Derek and Lisa Kaywood are running the community angle of this, and they're very much on board with the idea of not having a bunch of tools. And I wholeheartedly agree. So anyway, one thing that we have sort of started playing with is this new. It seems relatively new. It's like forums but for 2019. It's called Discourse, and I believe the guy behind Jeff Atwood, the guy behind Stack Overflow, is either jointly or solely, probably I think jointly responsible for this new project Discourse. But it's really cool. Like I said, it's like forums, but not in the 90s and early 2000s. And it accomplishes a lot of what we want. Not only is it everything Google indexable, which again, people learn through doing that. And so when people ask support questions, if we don't respond in a way where that information is then archived and made available to the rest of the world through Google searches, we're just going to keep having to re-answer those questions. And that's stressful for any project maintainer to have to keep re-answering the same questions, especially if they know that they're going to have to keep answering it because it's not being saved anywhere. And then Discourse has a very robust, seemingly badging system where you can give rights and privileges to post. We probably don't want to do too much with that. We kind of just want to allow everybody to post things. But we still do want to give credit for some of the lessons that they've done. And so we're really thinking about integrations between NRE Labs and Discourse. Nothing to share there. That'll be part of the version 1.0 design that we'll share in the near future, but just FYI, that's a heads up. If you would like to join the Discourse community, it's live right now. We haven't really published this. This is kind of the first time anybody's mentioned it. If you go to community.networkreliability.engineering, so instead of labs, just say community, it'll go to the Discourse page. Now, I will say it's very new, and so it's very skeleton really looking. So if you're looking at that and you're thinking of like, I would like to ask this question about how the platform works or how to contribute a lesson or any number of things, please ask it there. We're going to be getting some of the people that have contributed sort of behind the scenes in Slack and in Discord to push their questions in there so that everybody can benefit from it. So please join. It's not required. We're never going to require that you are part of that to use NRE Labs. But if you do authenticate to the Discourse site, you'll probably get some like extras, like the ability to track what you've done, things that you would expect. Nothing like hidden or anything like that, but just sort of additional context for what you've done. So very excited to share that in the future, but that's all I have for now in terms of tangible things to share. The next thing I'd like to do is whiteboard this issue. So let me first set the stage. Let me go to my stream settings and do screen share. And I will leave Road Podcaster enabled for now. And actually I want my webcam to be on top so that you can still see my beautiful face. There we go. Okay, so let me now go to Grafana. All right. So just to make sure you can see that, good. So this is these are the stats for lessons in progress for NRE Labs. Basically, what the backend orchestrator does, called Syringe, is it keeps track of the lessons that are in progress, and every once in a while it sends effectively a blob to a time series database, InfluxDB, and then this Grafana page is designed to look at that data source and display it and visualize it. Now, this is mostly not useful for the average Joe that's using the site. It might be kind of useful. It's mostly useful for folks like me who I want to keep track of like. For instance, especially early on, this was a very good indicator of any problems. If like there was a sudden die, it probably meant Syringe crashed, because the first thing Syringe does when it restarts is it cleans up all the existing lesson namespaces. And again, there's reasons for that. We don't have an external database, and so all the state is kept inside of Syringe. So instead of we don't want any straggling namespaces, so what we do is we clean it up. So this has been something that's been useful historically, but I'll say in the past few months it's been very not useful, and you can kind of see how it's been not useful because there seems to be an enormous not even spike, but just a gradual build over time, and as you can see, it gets reset every once in a while here and then here. You can see it goes down to 0, and then just inevitably it crawls over the course of days. In fact. This is just one day here. Over the course of several days, in many cases weeks, it just sort of naturally keeps building and building and building. Now, what you're looking at here is the different. They're actually overlaid on top of each other. The different lessons are the different colors represent the different lessons. And so, if you see this, for instance, you see not only is this lesson at 23 concurrent lessons. It looks like that's Introduction to YAML. So the graph seems to be saying that at this time, there were 23 concurrent Introduction to YAML lessons, 15 Jinja lessons, and then a spattering of others. So it's not just 23. It looks like potentially upwards of 50 or more lessons in progress. Now, normally my ego would say like, yeah, people are using NRE Labs, it's awesome, but I knew better. And certainly people are using it, but just not that many at once. at least right now. Usually the usage is much more predictable and sort of flat, because again, you only see these spikes if a bunch of people are using the same lesson. So if a bunch of people are using different lessons, that's how you get this like overlap effect here on the bottom. So normally the graph gets to about 1 to 4. 4 is generally the peak for, peaking out on a single lesson. That's about how much it's been. When we launched, it was a little higher than that, and then there were a few other events that we did, like an SE Summit internal at Juniper that we presented this at, and you'll see a little more activity. But generally, that's the pattern. The graph you're seeing here is very much not the pattern. And so what I want to do is explain how this came to be. And I want to go over how I stumbled upon this bug, and also before that I want to talk about why it's taken so long to fix it. So a few things to go over here. Let me first make my video bigger again. Center that up. I will disable my screen, and I will switch from Rode to the far less preferable webcam audio. So sorry, but slight audio degradation is just just how it's gonna have to be for now. Okay. And as you can see, I'm wearing my amazing NRE Labs lab coat, because why wouldn't I? It's just really cool. If you had a lab coat, you would too. So I call this murdering a bug, and actually I'm going to write a blog post on this. Just FYI, there's no, it's going to be really difficult for me because I still have some information gathering to do to properly recapture the nature of the bug. Sorry, there's some yard work being done under my window, so hopefully you can still hear me. So there's no way that I'm going to be able to capture all the aspects of this bug in this stream. I'm going to do my best to sort of visualize it for you, but just FYI, I'm working on a blog post that I'll be publishing later, hopefully later today, that captures like every little bit with some Kubernetes output and things like that. But the first thing I want to do is just go over the general architecture of Syringe and what led us to this problem. So Syringe is the backend orchestrator for NRE Labs and the Antidote project. What Syringe allows us to do is it allows us to specify a curriculum in simple text files, storing those files in Git, and then incorporating those into a larger set of other lessons and things like that. And then that Syringe is responsible for publishing that content via an API northbound to whatever's consuming it. And in the vast majority of cases, that's the Antidote web project, which is what you see when you go to NRE Labs. So Syringe is the system on the back end that has an API. It presents that API northbound to Antidote web. And I'm not going to draw that because that's not the point. The point is Syringe itself it provides an API to northbound to Antidote web, and then southbound it talks to Kubernetes. So when your web browser connects to NRE Labs, the JavaScript on the front end is designed to generate things like session ID via a cookie. So it's stored. That's the one cookie that we store. And again, that's the only reason we do that is to make sure you get back into the lesson that you need to get into. If you refresh the page, for instance, it's a way of just keeping track of who you are, and not in a personally identifiable way, just in a session. And just remember that we do that because that's going to come in handy with the cause. It's actually very relevant to the cause of this bug. So anyway, if you think of Syringe as an application that sits on the back end, and it publishes an API northbound, and the web front end consumes this API, so the JavaScript files that run in your web browser when you go to NRE Labs, they consume this API, and then northbound, or southbound rather, you can see that it communicates to Kubernetes. Make sure you can see that. Oh yeah, we got plenty of real estate. So basically this is what Syringe is. And like I said, please don't get married to the architecture I'm about to talk about because this will change, but right now, all of Syringe, at least the server side, there's a client as well, but that you can run on your laptop for things like validation, but the back end is just one single binary. So everything is just in this one single running process. And so everything that I'm about to talk about are the internals of Syringe, of the back end binary here.
So that's the high level what Syringe does. I'm gonna draw a bigger box and then talk a little bit about the internals of Syringe. So this big box is Syringe. That's terribly small, you won't be able to see that. So this big box is Syringe. As I mentioned, Syringe is one single binary. But in order to do the things that we need Syringe to do, currently it's separated into two logical components. So these are not separate processes. It's still one process. But one of the cool things about Go is that it allows you to manage concurrency very, very efficiently and very easily. Really, it has a lot of really awesome primitives for handling that stuff. So this is not a process differentiation. This is all one process. But inside of Syringe, we have two logical components. We have the API server, and then we have the scheduler. And actually, before I go any further, what I'm going to do is I'm going to separate the two. Again, please keep in mind that this is just one process, but I'm going to give myself some space here because I want to talk about how they communicate with each other, how these two components communicate with each other. So that's the API server, and this is the scheduler. So if you think about the different, components, there's two main components, again, all inside of the same running process. The API server is responsible for, as you can imagine, it's responsible for providing the API that the front end consumes in order to make lessons work. And so we have all of our API definitions in Google Protobuf, and those protobufs declare services, things like request new lesson or get new lesson. So all of the API endpoints that you might expect and that you can see in our docs actually are provided by this component. Again, all one running process, but this component is designed to provide that connectivity northbound. And it also does some other things like keep track of states. So if you, I wish I had left myself some room up here. Let me make this kind of, there we go. It's not the perfect, it's not a perfect square, but it's fine. So the API server part of Syringe, it responds to outside requests. And so if you initially send a request into Syringe, but just by going to the website, again, the JavaScript in the Antidote Web portal would be doing this. Sends a request in, it's like, I need lesson 12. So basically, you've gone to lesson 12, which is the JSnappy lesson. It's another byproduct of having worked on this very intensely for 4 months, is I have most of the lesson IDs memorized. I would say that's cool, but it's actually more on the sad side of things. That's okay. I don't mind it. So lesson ID 12, and the other thing that it needs, this is also something that's done on the front end, is a session ID. So you have a lesson ID. I want lesson 12, but who's requesting it? And how do I keep track of who requested it so that if you request it again, I know who to send, what kind of data to send to you. So usually this is some sort of, it's all just, I can't remember how long this is, but it's just alpha, it's not even alphanumeric, it's just alphabet. So 26 letters possible, and then some length of characters, let's say 10 or 5 for the sake of argument. So A, B, C, D, E, F, or A, B, C, D, E. A, B, C, D, E. And then actually the stage is sent in, but that's optional. So these are the two required fields for requesting a new lesson. You need to specify who you are, meaning the string of characters that the front end, meaning the JavaScript client that's in Antidote Web, what it generated for you, and stored as a cookie in your browser. So that is what uniquely identifies you when you go to the site. And this session ID is important because it keeps track of the lesson resources based on the session ID. And then of course you want the lesson ID. Which lesson do you want? Which lesson are you trying to load? And then so together, these two actually create a sort of a session ID of their own, or a UUID that's carried throughout the system. But generally, just FYI, the request endpoint requires those two things. Now, what happens is that request endpoint has some logic in it. It does some basic sanity checking, like, hey, does lesson ID 12 actually exist? If it doesn't, I'm just going to throw an error right away. So there's some simple stuff that we do within the API server, again, there's some logic. There's a lot of logic here actually that does stuff like that. Just basic sanity checking, kind of like a security guard. You know, they're not going to stop they're not going to stop like an invasion by a military, but they do some of the basic stuff to make sure like people don't try to rob the place. So we have a security guard kind of functionality within the API server. The old sneeze coming on. Excuse me. The other thing we do is, of course, we want to be able to allow people, if they have a running lesson, and let's say they had to shut their laptop and run to a meeting, if they want to open their laptop again and like refresh the page, we don't want to have to re-provision the lesson from scratch. We'd like them to get access to the same lesson that was provisioned before, again, assuming it still exists and hasn't been garbage collected. And so the way that we do that is we actually keep track. There's a table within the API server itself that keeps track of session IDs, meaning like 12, it goes 12-A, B, C, D, E. And then the value for that key, it's a key value, it's a basic key value pair. And then the value for that key is all of the lesson details that actually is relevant to the scheduler. So the reason we have this here is, again, if we send a request initially, the first thing that this API server is going to do is it's going to check this table to see if it exists. And if you're running this for the first time, it doesn't. So what it's going to do is it's going to say, okay, cool, I'm going to request that this lesson gets created. But the very first thing I'm going to do is I'm going to add an entry into this table so that I keep track in my head, meaning the API server, it knows that there's a lesson in progress with that lesson ID, with that session ID. So that's pretty cool. The next thing it does is it records that state, and the next thing it does is via a Go channel, which is a way that different Go routines can communicate with each other. And by the way, the API server and the scheduler run on separate Go routines, so these are running in parallel. These don't have to run together, but they do have to coordinate. And one of the ways they coordinate is through channels. So there's a channel that goes in this direction, and then there's another channel that goes in this direction, which we'll get to in a little bit. But this channel is designed to have messages on it that say, hey, API server needs to send a message to the scheduler. And again, the very common use case for that is requesting a new lesson. And so I say, hey, I want a new lesson. API server says, cool, I don't see that yet, so I'm going to add an entry into my state, into my internal state, so that I do keep track of it now. And then I'm going to send a request down to the scheduler and say, hey, scheduler, please go make this lesson happen. So the API server doesn't talk to Kubernetes at all. It's designed to talk northbound to the front end and then keep basic state about requests that have come in. The request that's sent from the API server via this Go channel, and this is all in memory again, this is all one process, and so this isn't an API, this is just a Go channel. The scheduler receives that message and says, oh, looks like we have a request for a new lesson. And based on the lesson definition, which is in YAML, but imported into Syringe when it boots, so it's going to have all of that lesson definition in memory, it's going to say, oh, it looks like lesson 12 requires 3 VQFX images, and JSON, and the lesson guide is this, this file, and a bunch of other stuff. So all of the stuff that's in the lesson definition, the scheduler now knows it needs to actually create because it's being requested to create lesson 12. So what that does is it goes through and it talks to Kubernetes. I assume you can still see that? Yeah, barely. So it talks to Kubernetes, and then it actually has its own state, which we're using, but not really in this case. It has its own state, but it's not relevant to this conversation. This is the state that where we had the bug I'm about to talk about. So it keeps track of like the specific Kubernetes resources, like things like pods and services and things like that. It pops it into here so we have a record of it. Now again, all of this is in memory. This is not an external database, neither this or this. It's just in memory. I should say that. So if this restarts, all of it gets wiped away, which is fine because it's just running lessons. It doesn't need to keep track of any of this. Everything that needs to be persistent is in Git. Let's see. Sorry, I keep going down these rabbit holes and I shouldn't. That's probably confusing. So the scheduler receives the request, right? So the scheduler receives the request and says, I'm going to go fire off to Kubernetes and talk about all these, kick off all these things. And actually, I'm going to end that there because nothing in the scheduler is cool, but nothing in the scheduler is relevant for this bug. At the end of this provisioning process, let's say it takes, 5-6 minutes to boot a lesson, which actually isn't uncommon. That does happen because sometimes like VQFX devices take a while to boot up, and then of course they have health checks that need to run, and then of course they need to be configured, and so we got to go call Napalm to configure them. The scheduler takes care of all of that. So based on the lesson definition, based on what's in the lesson, all of that happens, and once it's finished, the scheduler sends a result back to the API server. Now that result is designed to update this state. And the reason for that is because in this state, like I said, the key is this combination of lesson ID and session ID. The value that's stored in here is basically a JSON blob of all kinds of attributes of that lesson, specifically if the lesson is ready or not. So when we first receive this request and record an entry here, naturally we know it's not ready because we haven't told the scheduler about it yet. So we just say, hey, this lesson's not ready. And so then we fire a request off of the scheduler, and then we keep chugging along here and doing whatever. What this means is, if you fire another request, or there's actually a get function. So this is, I would like to request a new lesson. There's also a get function which simply says, hey, give me the latest information on this lesson, and it has similar information. So 12 ABCDE. Give me the latest on this particular lesson. And so it just simply looks into that table and provides the result that's stored in the state. And again, if we've just requested this, the lesson's not ready yet, and so the response to this API call will be, no, you're not ready yet. So what the front end actually does is it calls this once, and then it calls this once every second after that. It just keeps calling it. And it keeps calling it until this state responds with, yeah, you're ready to go. And then it stops calling it, and it starts using the lesson. That's why the state is here, so that we can constantly know whether or not the lesson is ready. Now, the way that we know the lesson is ready is, as I mentioned, the scheduler goes forward and creates everything that it needs to create. And then once it's validated that the lesson is up and ready to go, it sends a result back to the API server. Now, the API server is listening for these messages from the scheduler. Just like the scheduler is listening for the request messages, the API server is listening for these result messages. I'll draw that out. The result messages are actually fairly simple. They're not designed to do much. The only reason these are sent is so that the API server can update its state. It keeps track of the state of all of these lessons that are in progress, and then it uses that to inform further requests. And so what happens is when the scheduler finishes provisioning a lesson, it sends the result back, and Syringe or the API server says, oh, looks like this lesson is ready. I'm going to update the status in the table so that the next GET request sees that, and then it knows that it can start using the lesson. Now, there are other reasons why this result would be used. It's not the only type of result message that is sent. Certainly, it's a pretty common one. If you're done provisioning the lesson, you want to let the API server know. But there are other result messages that are sent too. And actually, some of those results aren't the result of any request by the API server. Sometimes the scheduler just does stuff on its own and just needs to inform the API server about it. And one really, really good example of this is garbage collection. So, and this is a configurable value in Syringe, and by default, and this is how we have it set in NRA Labs, a lesson will time out after 30 minutes. And by timeout, I mean if you haven't done things like refresh the page or navigated between the labs within a lesson, there are a few things that you can do to sort of to reset the clock, as it were. But if you haven't done any of those things, in 30 minutes, the scheduler is aware of that, and it's going to delete the lesson. And you can recreate it if you go back to the page, and it'll have to recreate it for you. Instead of what it would normally do is if it was running, you would just load the page and it would instantly be there because it's already running. So if it gets garbage collected, it'll have to re-provision, but it'll take some time. So when the scheduler, like I said, the API server doesn't know anything about garbage collection. The scheduler maintains that knowledge. It knows, obviously it's talking to Kubernetes, and it can ask Kubernetes, hey, how long have these lesson namespaces been active? And it compares that with the timestamp of the last time that somebody did something with the lesson, and then based on that, it decides which lessons to destroy. Now, of course, after it's destroyed a lesson, so it says, this is the garbage collecting go routine within the scheduler. It says, hey, Kubernetes namespaces, delete the namespace associated with this lesson. And that's really cool because I don't have to worry about deleting specific resources. I just delete the namespace, and everything in that namespace is cleaned up. That's really cool. And this works. This has worked very well for the whole time. This isn't where the bug that we're encountering is. So remember that graph showed all of these lessons continually growing. If you look at the Kubernetes namespaces, that's like the source of truth, really. Now, obviously, the namespaces and the state should be in sync, but they're clearly not. If you look at the Kubernetes namespaces, if that graph said, hey, you've got 50 lessons in progress, and you go to the Kubernetes namespaces with kubectl, like you say kubectl get ns, then you'll see that there are like there's like 1 or 0 namespaces. So clearly there's a mismatch between the two. So what happens when the garbage collection takes place is it deletes the namespace successfully, and then it sends a message back to the API server, so the API server knows to clean up its local state. Now you're probably anticipating what comes next. Clearly, there's a problem with how the state gets cleaned up, and you're not wrong, because obviously, if there's more entries in here than there are namespaces for lessons, yes, clearly there's some sort of a problem with communicating that result back to the API server. But it's not as simple as that, because if it was just that simple, like there was a problem communicating between the two, then we would never see deletions in this list. We would never see sessions get deleted from this list, and we were still seeing a lot of lessons getting deleted. It wasn't like every single lesson stayed around in this state. It was roughly 8%, and I mean 8% very specifically because I now know, because of the nature of the bug, it is 8%. And by the way, I should mention this. InfluxDB is sitting over here. This is a separate process. It's not part of Antidote. It's a separate open source project, and it's awesome, by the way. You should check it out. It's a time series database. And then on top of that, we have Grafana, which is the graphing application that you saw earlier. And there's actually a process. Again, this is going to change. This is not ideal. But the way we have this currently working is there's a teeny little Go routine inside of the API server that's designed to look at that state and then export it to Influx every minute or so. So it's pretty simple. It just takes a snapshot of whatever's in the state, sends it off to Influx, and then shows it in Grafana. Which means that as we see this graph grow, that's a reflection on this state being reset. Now, this is the problem with this bug, is it wasn't every single lesson was not. It wasn't that like every single lesson was getting failed to delete here. It's most actually were getting cleaned up. It's just that every once in a while, one of the launched lessons would stick around in this state. And of course, over days and weeks, that would slowly grow and cause problems. Now, normally you would look at that and be like, well, so what? People still have their lessons around, and you just pay for the cloud costs, right? Well, remember what I said. The Kubernetes namespaces are getting successfully deleted. So the compute stuff is getting cleaned up for every lesson without fail. That's worked really, really well. It's just the copy of the state that Syringe keeps in the API server has become out of sync. Now that's a problem because, again, as I mentioned, if you send a request in and the state is here, it's just going to send you to the lesson because it's going to have that state stored here in the value, literally IP addresses and ports that you need to connect to, because if the state is here, the assumption is it's live and ready to be connected to. Because, again, that's the scheduler makes these assertions on, like, is the lesson live? And if it is, I'm going to send the result back to the API server and say, yes, it's ready to go. If this never gets cleaned up, but this gets deleted, then the user is going to be presented with a result from their GET request that says, yeah, your lesson's ready to go. But it's not. It doesn't exist. And so for the small number of people that were affected by this, they would actually be able to successfully load the page, but they wouldn't be able to connect to anything, which is so frustrating. So frustrating. And that's all for my whiteboarding. I'm going to leave this percentage up here. For 8% of you, I am very sorry. Because I looked at this situation, and I saw the graph slowly growing. Clearly there's a state problem. But I'll be the first to admit, I got a lot of stuff to do. And I looked at the graph and I'm like, there's a problem to be solved. Let me, the first time I saw this, and several times since then, I've gone into the NRLF portal, loaded up a bunch of lessons, and it works. Like, everything worked for me. And I'm like, well, and nobody was complaining. That's the thing. Nobody was saying anything to me about this issue. It was just something that I was observing with the state on the back end. And so I was like, man, I got a lot of other stuff to do. It seems to be working. I'll fix this later. I need to fix it. It's obviously a problem, but it doesn't seem to be user impacting. So I just kind of took it. I just put it aside for a while. And yeah. I am sorry that I did that, because for the 8% of people who were affected by this, they had a horrible experience. And I wanted to explain this because I wanted to make it clear why it's 8% and why we're going to fix it. So hopefully I've described the problem. I haven't talked about the solution yet and how we fixed it, or at least the symptoms of the problem. What I'm going to do now is I'm going to go to my computer and I'm going to talk about, I'm going to show the cause of the problem, the reason all of this happened, and I'm also going to talk about the solution, how we fixed it. Oh, there's my StarCraft poster. Okay. There we go. Fix my camera here a little bit. All right, so let me share my screen again, switch over to the road.
Turn off the webcam audio, so hopefully this sounds a little better. Okay. So yeah, so this is a problem, and as you can see, it's not like it's a steady increase. If like I said, if every single person was affected by this, we would never see any of these graph lines go down, meaning it would only ever increase. But it's not that simple. We were seeing decreases when a lesson is garbage collected, it goes back down. The usage goes back down. And so clearly garbage collecting was working, and the way that state was being recorded was working mostly. It's just every once in a while it seemed like the floor for these graphs was raised up by 1 every once in a while. Again, over the course of days. That's why we had this steady growth. It wasn't linear growth. It wasn't like every single time a lesson was launched, it would go up 1 and stay there. It would be 1 out of 10 would cause this to happen, cause this floor to get raised and eventually go up. And then of course I would reset Syringe and I would be like, okay, well all the states cleaned up, and then of course it just kept creeping back up. So that's a problem. Because again, for all of those people that connected, that have that state that's stuck in Syringe, unless I restart Syringe, those people are going to be trying to connect to lessons that don't exist. And they're not going to be able to use them. They'll be able to use them once, and then they'll be locked out, basically, until Syringe gets restarted. So, on a whim, I was working on a similar feature. In fact, I was thinking about doing some of the architectural changes I alluded to earlier in Syringe. And so one of the things that I did, and I'll show this better in the blog post. I'm on my Windows machine so that I can stream. The blog post will have a lot of the details from like Kubernetes perspective. But one of the things I wanted to do was do better at managing the state inside of Syringe. And so I was making some adjustments. And in Firefox, actually, I think in Chrome you can do this as well. I would imagine in any web browser you can. But in Firefox anyway, I was in Firefox. And I went into the storage tab for the web browser, where you can actually look at the cookies that each website stores for you. And you see the cookie that the JavaScript for EnteryLab stores, and I can edit it. So instead of that random, the random set of letters, I edit it to Mirden prod session, something like that. And as it turned out, the fact that I did that was the most serendipitous, lucky thing I could have ever done. I imagine I would have fixed this eventually, given enough time, but I definitely would not have felt the motivation to fix it had I not done that. I did this yesterday, and I dropped everything the moment I did that, because every single after I made that change to my session ID, every single lesson I launched, every single one, had this problem. Meaning I would launch it once, and it would work, it would connect. I would wait 30 minutes, it would get garbage collected, and then I would try to reconnect to it, and it wouldn't connect to anything. The page would load, but all of the lesson resources would be unavailable. And that wasn't for a small percentage of my lessons, that was for every single one. And so I'm like, damn, that is bad. Excuse me. So that got me motivated. I was convinced that this was a problem, and so I started looking in earnest for the cause. And as it turns out, I'll just sort of cut to the chase here. I'm gonna explain the details behind that why. But as it turns out, if you go to the API server, so as I mentioned, there's 2 components. There's an API server and the scheduler. If you go to the server.go, and you go to the lesson or the result handlers section, you'll see that there's a for loop that's running and constantly gathering result messages. And so it's this is where it receives messages off the channel, and for every message that the scheduler sends, it decides, okay, what function do I need to send you to based on the message type. So if the message type is operation type delete, for instance, if the scheduler garbage collects a lesson, the scheduler will send this message to the API server. The API server will receive it, and it will say, hey, you need to go to this function to get processed. If you go back out to the parent directory and then you go to result handlers, you can see that that function is defined here. Handle result delete. Now, this is a really simple function. It's not very complicated. It just runs a single call where it says s.delete live lesson, which is just a helper function that removes a live lesson from that state entry. So remember I mentioned there's a state table in the API server. This function is designed to take in the session ID, or the UUID really, which is the lesson ID combined with the session ID, and delete that entry. What it does is if the session ID that you pass into it, or the UUID rather, which is both the session ID and the lab ID, or lesson ID, if it doesn't exist, it just doesn't do anything. If it does exist, it's safe. It locks the state, deletes it, and unlocks it safely. So it's basically a easy function. You just pass a value in, and if it exists, it gets deleted. If not, it doesn't do anything. It just sort of silently does whatever. Now, this is a problem. Well, actually, that's desired behavior. The problem was because I was using this strings.trimWrite function right here. So strings trim right go. Let's go to the Go doc for that. I think, yeah, here we go, yeah. Okay. So if we look at this function, basically, let me go back to the code real quick. What I wanted to do was take off the -ns after the UUID, because we append the -ns for when we declare Kubernetes namespaces. So long term, I'm probably just going to get rid of that altogether, because it just causes too much trouble having to remove this before we pass it into another function. But normally it wouldn't cause a problem. It's just a little extra work. The problem came because I'm using the wrong function. In this section, my intention is to remove the trailing -ns from the right of the string. And I remember writing this code, I briefly perused the Go doc, and I was like, yeah, it looks like what I want. It's not. It's not what I want. What I want is trim suffix. If we read trim suffix here, you can see trim suffix returns s without the provided trailing suffix string if s doesn't end with the suffix and s is returned unchanged. So kind of like my delete function, it takes in a string and then the desired suffix, which is exactly what I'm sending to the other function right now. And it simply says, hey, does this suffix exist on the end of this source string? If so, delete it and return the result. And if not, return the original string. That's what I wanted. But instead, I selected trim right. Let's take a look at what trim right does. Trim right returns a slice of the string s with all trailing Unicode code points contained in cut set removed. This is a very important distinction to make. If we go back into the code, what it's saying is, it's going to look at the end, it's going to look at the right of the string. Indeed, it's going to look at the right of the string where the -ns is, and it's going to start at the right and it's going to move left, one character at a time. If the character it's currently looking at is contained within this string, meaning if it's a hyphen, if it's an N, or if it's an S, it's going to delete it. And it's going to keep going until it finds something that's not in that list of characters. Even if they're not together, even if it's like just an N or an S, it doesn't have to be -ns, it doesn't have to be the full string, it's an or. If it's any one of those individual characters, it will delete it. And it will keep deleting it until it finds one that's not one of those original characters. Now, obviously, at the end of the UUID, for every namespace, there is a -ns. So it will still delete those last three characters, just like the trim suffix would have deleted it. But it won't stop there for the 8% of cases where the session ID ends in an N or an S. Now, it won't have any hyphens in it because that's it. Like I said, it's just alphabet. The alphabet is there. So for 2 letters out of the alphabet, 2 out of 26, which is 1 over 13, which is 8%, it will start deleting characters from that session ID, which is bad. Because at that point, once you've deleted those extra characters, that session ID is not in the state. It's not in the state table for the API server. You've basically eaten up too many characters in that session ID. And when it says, hey, I'd like you to delete the session ID, the delete live lesson function says, there's nothing in my records with that session ID, even though there's a session ID in the state table that has those characters, but a few other ones that got cut off. So if your lesson, or if the session ID that was generated by your client, meaning the JavaScript on the front end, ended in an N or an S, you suffered from this bug, which statistically is 8% of you, because it's all randomly generated. Now back to the session ID that I used. The reason that was so lucky is because I said my session ID that I manually typed in so that I could keep track of my session visually when I look at output and logs, things like that, was Mirrodin PTR, or Mirrodin prod session, ending in an N. That was a very lucky thing to have happened, and it allowed me very quickly to figure out the cause of the issue. So, very long-winded way of describing the problem. Hopefully that was interesting. I want to caveat, well, 2 things. I want to say the fix is really easy. Simply change trim right to trim suffix. That's step 1. Step 2 is, in the future, read the docs, Matt. It's probably a good idea. Shameful that all of this was caused by a very simple wrong function. And oh, by the way, this is another thing I want to say. You might say, well, don't you have tests that catch this? Yes, we have tests that run this. But it's only 8% of possible session IDs. And we're not randomly generating them in the tests. We're statically generating them with like A, B, C, D, E, F, that kind of thing. So yes, we have tests, and yes, we will start randomly generating them in the tests as well, instead of just using static defined ones. So we statically defined a session ID in the tests with A, B, C, D, E, F, and so every time we did garbage collection, all the state got cleaned up perfectly because it didn't have an N or an S at the end of the string. And so we didn't catch this in tests. We will randomly generate the session IDs inside of the test suite in Syringe from now on. And then at that point, again, we would only catch a problem 8% of the time, but it would catch it. Now, of course, we're fixing this issue, so this whole 8% thing is not going to. Hopefully, there won't be another issue lurking somewhere about that has the same nature. But if it does, I'll know where to look for it. So the fix is easy. Change trim right to trim suffix. I do want to mention that I actually already went back into the version 0.3.1 branch for Syringe, which is the latest release. I manually patched that and published a new version of v0.3.1 and pushed it and started running production on it. So if we refresh this page, and let me actually zoom out. I wonder how well. Let me go back out to dashboard actually. Oh, there we go. Yeah. So this is way more reasonable. This is what this looked like for a long time, before the bug was created a few months ago. At launch, this is what the graph looked like. Very useful. I can see beyond a shadow of a doubt what lessons are in progress because this state is in lockstep with the Kubernetes namespaces that exist. So the patch has been applied. This bug has been squashed. And the last caveat that I want to offer is, hopefully this was useful in terms of, first off, as an apology. As I mentioned, I'm sorry that I just neglected this issue and assumed that it wasn't a problem. For 8% of you, it was a bad problem, and you couldn't use NRE Labs effectively. So for that, I apologize. We will try to do better at that. If you have any issues in the future like this, please do not hesitate. There's only so many things that we can try to monitor on our own. We still require a lot of user feedback. Please tweet at us at NRE Labs. Go to our documentation. There's a community page that contains things like our Discord channel and our discourse site. All kinds of ways to let us know. Please, 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 if you have issues, just send us a heads up. If we're not aware of it, we can't fix it. And then the final caveat that I'd like to offer is just keep in mind all of this is going to change. In version 1.0, Syringe is actually going to break up into little microservices, and all of the state is actually going to be managed by an external database. We're doing that we were sort of proud that we didn't have an external database at the beginning, and we still are because it's very simple. But there are known scaling limitations for that. We won't be able to scale past a certain point if we just try to keep everything in memory. And then certainly, obviously, failure scenarios are there. Like if Syringe crashes, we got to restart Syringe. And then, of course, clean up all the namespaces as a result. And it's just it's not fun for everybody. So we gotta break some stuff apart. As a result, just keep in mind the architecture that I talked to you about here is going to be very, very different in version 1.0. So don't watch this video and be like, I now know how Syringe works. You do in its current state, but it will change very rapidly over the next few months. This was mostly an academic exercise. So let me, because I'm a solo streamer today, I want to be sensitive to the fact that there might be questions in the stream chat, which I haven't been looking at. So before I say sayonara, I'll take a peek at that. I saw a chat message before I disconnected. Or refresh the page, rather. But I'm not sure. It said, what's happening, Matt? I'm not sure. I'm streaming. I'm not sure. Whoever asked that question, hopefully there was not a problem with the stream while I was away. It did say there was a network error, but that was on the Twitch site itself. So I'm assuming it was a network error for me seeing it and not a network error for me streaming. Looks like 0.4% dropped frames. It's not too bad. So yeah, I'm not sure. Hopefully the stream was okay. Hopefully there weren't any other issues. Let me disable screen share. I'm going to look at Twitter now. No questions on Twitter. Okay. Well, you know where to reach us. If you have any future questions, feel free to ask. Like I said, on the page for this, if you go to nre.live, you'll see links to everything. You got our docs with all our community links. So you can go to our Discord channel for asking questions. We're in there. We're in the discourse. It's the new discourse site, which is community.networkreliability.engineering. So stop by there and help us build that content because it's a totally new site. There's really nothing in there right now. So please put a bunch of questions in there. Help us fill it out. And then, of course, you know where to reach us on Twitter, at NRE Labs, which is a direct line to me and to Derek. So thanks for watching. Hopefully this was useful, and I hope that there weren't any stream issues. I'll be really pissed if something happened in the middle there, because I went over a lot of stuff. And if this kind of deep dive is your thing, I would love to hear feedback on that. I know I rambled a little bit. It's sort of my nature. If you found this useful or not useful and you just don't want to do this kind of thing anymore, you'd like it to be a little more like screen share kind of stuff, like whiteboarding or whatever, all of that feedback is good and valuable. So please just speak up and help us improve this. This is something we're doing for the community, and we want the community to have a huge amount of input, in fact, the most input for what we're doing in the future, including the live streaming as well as the project itself. So with that, I will say goodbye, and I'll see you next week. So join us next week at 10 a.m. nre.live, and you will see the stream next week. And then feel free to subscribe. Twitch, YouTube, we're going to publish all videos to YouTube like we usually do. And that'll happen later today. All right, sayonara. Thanks, everybody.